Hello guys, this is the fifth lesson of the C++ programming language. Today we are going to talk about how we're going to define a class and its function in C++ programming. But firstly, we need to describe all the features and purpose of the class and objects in C++ programming. In C++, the main purpose of C++ programming is to add object orientation, which means that we have a one variable like integer a, but we need to add or we need to reach this variable by using this variable, and we're gonna need some calling function in here or link with a to b by using the class structure. And so the object orientation to the C programming language and classes are the central feature of C++, to be defined as the object orientation. In the definition of class, a class can be described or can be used to specify the form of an object, and it combines the data representation and methods for manipulating that data into one package. Which means that if we're gonna create a variable from the feature of the class like box or myClass type, then we can call some function related to this variable, and we can call some variable especially in this class structure. So class covers all these features at that point. Okay, in C++, we can split the explanation of this as a two parts: a structure and its function. Which means that class consists of its structure and its function. So we have two rules in here. One of them is the syntax rule, and one of them, the other, is the semantic rules related to its function. And the former, which means that the syntax rule, shows us how to use in C++ programming with a proper structure. Okay, a class definition starts with a keyword class followed by the class name, like this. Class is the keyword of the definition of the class, and then we're gonna need, or we need to specify some specific name for this class. For example, my class. And then we need to add this bracket in here, and we need to put at the end of this structure. This is the structure of the class definition. A class definition must be followed either by a semicolon or a list of declaration. Either we can define the variable in here or in here. And so, for example, we can define this class structure in here, and then we can create an integer value related to this class variable. So we can add the first example in here like this. We need to include some specific library at that point, and we need to use the using keyword to use namespace std standard definition, and then we're gonna need integer main function to execute the starting point for the C++ programming at that point. Okay, if you run this program by pushing the Ctrl F5, and then we have no syntax error in here, so the structure of the class is correct at that point. The difference from the struct variable in C++ programming, like this struct, for example, note, in here we can define integer a in here with the name of the note, but we can define also the class variable in here. If you run this program, there is no error in here, but there are basic differences at that point. If we use the struct keyword or struct structure types, we don't have any function or essential operator in here. And so in C programming, we can use the struct node, but we cannot use the class variable because the class is included only in C++ programming. And so if we have some specific variable, or if we have some specific class, then we can create a variable, or which we call the instance variable, in main function, and then by using this class variable, we can call some specific function in main block, which we call the object orientation notation in object-oriented programming. So if we want to create a variable in main function, we can define, or we can give the program the class name with the variable name of the specific name of, for example, m1. So if we want to create or build some specific variable about a class variable, and then we're gonna use this syntax. Firstly, we want to give, or we need to give type, and then we need to give the program a specific name to represent the whole feature of the my class notation. And then we can build, or we can run this program, then there is no error at that point. Okay, so that's the first example related to the class experiments in here, and then we will talk about its structure at that point. In C++ programming, class structure is divided into the 3 section points. One of them is public area. One of them is the private area, and one of them is the last one is the protected area. These structures are given to the program to represent the access attributes of the members of the class that follows it, which means that if we define integer variable in public section, we can reach a variable in the main function, but we can define integer b value at this point, and then m1 does not reach the integer b value because it's the private elements of this class in my class experiment, which means that if we're gonna use this variable in the main function or the outside of the class, we need to put all the variable to the public section. So in that case, we need to create all the variables in public section. But why we are using the private section at that point? Normally, class definition includes some specific function definition or include some specific function in the class. If we're gonna create a function block in here, which means that display function, at that point we can define some this notation at that point. So we can run this program and we don't have an error, but we can define some specific function to call in main function block. So m1 dot, which means that if we use this operator or this dot function in here, then we can reach the a variable in here, and then we can assign some specific container elements or the numbers in here, like the 5. And then from the difference, or we can differently use this function block in here. Normally in C programming, we need to use this notation. If we want to call a function, and then we can define void display function at that point, and we can write some code in here, and then if you run this program, then hello world is in the output. But if we create a class function included in the class definition, in that case my class has a function block to represent the display function. So we can assign 5 to a variable, but m1 a variable to 5, and then we can display a variable at this point like this. And so display function in here is the element or is a member of this class variable. So we can call display function in here like this. By using this dot operator, we can reach all the member function in here, and then we can display or we can call some function related to the m1 variable. Then we can run this program, and then we have a is equal to 5 in the output point. This is the definition of object-oriented programming, or an example of the object-oriented programming. But in object-oriented programming, or by using this class structure, we can define many variables like m2, But m2.a is equal to 3, and we can call display function for m2 like this, and then we can call this function. And so in the first place, m1a is equal to 5, but in the second case, or in the second place, m2.a is equal to 3. But display function is included in both variables, which means that the class feature shared by the variable, or by the instance of the class elements. This is the powerful elements, or the powerful strange thing by using the class structure. So we can define many variables at that point, and then we're gonna pass the next example to learn about how we're gonna use the class structure in here in the example 3. So at that point we need to include some libraries in here, and namespace should be added to the program, and int main function for a starting point should be given in here. So we can define a box class in here, which means that there are some box with a volume value, or with having a volume value and area value of this box, and all the member, all the variable of the box shares some specific point, which means that we can use public keyword in here, and every box has length variable, and every box has breadth or width variable, and every box has height variable in here. This is the shared property of this class. And if we're gonna use, or if you're gonna create a variable typed by the box, and this variable has this kind of feature, and so we can assign all this variable, like with the definition of box. We can use the box notation in here as the parameter of box1, and box notation here box2 as a member function, or the instance of this class, which means that box. So we can define a volume value at that point, and then we can use box1 height is equal to 5, box1 length is equal to 6, and box1 width is equal to 7. Then we can calculate the volume value of this notation for the box value, which means that this is the volume 1 variable in here, and then we can product all these things at that point, and box1 height, no length in here, and we can print out this variable volume of box1 is equal to volume 1 and li. Okay, but this only related to the box1 variables. we cannot touch, or we didn't touch the box2 variable at this point. So we can run this program like this, and then the volume of box1 is equal to 210. We don't know the units, but who cares? Okay. It's the same structure, can be applied to box2 variable, but 1, 1, 1, and volume 2, 2, 2, 2, and volume of box2 can be defined by this definition. Okay, 0, 0. Okay, and we can run this program and we get this value. Okay, but this is the same function is applied everywhere in the program notation, because box has a volume variable, and then we can define as a function block to calculate this volume value. So we can generalize this code. So we can write a specific function to sharing all the box variable in here, like this one. For example, the function name is getVolume variable in here with the parameter of void, and then with the return value type of double can be given at this point. And so we can calculate the volume value of these parameters, like this one. We can define double volume in here with the initialization value of 0, and we can return length times width times height at this point. And so in the second example, if we have this function block in the public section, we can use it down like this one. Box1 dot get volume value gives us to volume of the box specified by the height, length, and width. So we can write it down as volume of box1 in here, and Lee should be added in here, and then cout volume of box2 at this point. Oops. Okay. Box2 get volume function can be called in here because it's in the private public section at this point. And then we can rerun this program. Then we have the same results, but it's the only difference is that we have get volume function in class variable. In C programming, structure does not provide this feature, and this feature is powerful to create an object-oriented notation in here. So we can define many function block at this point. So we can pass the fourth example in here like this one. Okay, x4, and then box1, box2 can be given in here. Okay, but what if this variable is included in the private section? Now, in the main function block, box1 dot length cannot be reachable because a member box length is inaccessible because it's included in the private section, which means that only class scope can reach this variable. So we need to define some specific function to reach out this function block like this. Void set length function with parameter of void can reach this private block because this function is included or is covering in the class section, class scope in here. So length can be updated in here because this scope, class scope, covers this function as well as this function. So if we want to reach in the main block, we cannot. But if we use the function block in the class section, we can reach the length variable. So we can't pass the parameter of L at this point, and we can assign a length to the L variable in here. So we can derive this notation for the white like this one. White can be updatable for V, and height function can be called to update height variable in here. Okay, so box1 and box2 can be reachable by using this function block. But box1 does not show the specific value of the private variable or private object in the class notation. So set height can be called by 5.0, and box1 set length can be called by 6, and box1 dot set height can be called with the 7 values, and length, width, and height are updated by using this function. So we can call this function in here the get volume, and we can rerun this program, and we get 210 for the volume of box1. Same procedure can be applied to the box2 variable in here, box2, box2, box2, and 2, 3, 4 in here, and then volume of box2 can be passed this function, and this is the 24 value of this function. Okay, so this is the fourth example of this session, and then we need to pass the constructor object, which is the primary feature for the class structure in C++ programming. It's important. So we can define some specific function in here, and we can define the class constructor and destructor at this point. In this lesson, we can pass or we can define a class constructor at this point. A class constructor is a special member function of class that's executed whenever we create new objects. A constructor is a constructor object for this class. If we use this bus function in here and then compiler writes constructor automatically. So a constructor will have an exact name as the class and it does not have any return type at all. Constructor very useful for setting initial values for certain member variables, like the length, width, height for a given box class at this point. So, in the first place, we can delete all this session in here, and in the public session, we can write the box constructor like this. So, this is the default constructor for a given class in here. And leave. Okay. And if we create a one variable of box in the main function, the constructor is automatically called by the compiler, like this one. Okay, this is the default constructor of this project or this program. So we can note it down as constructor is a constructive or builder object function for a given class in here. Okay, like this one, destructor is a destructive object or function definition to delete all the box variable or all the box properties for a given program. In this case, the main function calls constructor at the beginning of the definition of box variable, and then destructor is called at the end of the program because the scope is ended or finished. Don't you agree, Özanç? Okay. We have an agreement with my beautiful student. Please note that. So, for a definition of destructive object, we can define by using the tilde operator or not operator in here, and we can write down a destructor. We can write it down as this property, and then if we rerun this program, then we have default constructor at the output, and the end of the line we call destructor automatically in here. So we can set all the initial points or the initial we can initialize all the variable included in the private section length, width, height in the constructor, which means that length is equal to some specific point 5 and width is equal to 6 and height is equal to 7 at this point. And then at the end of the box or destructor, we can assign this variable to 0. But it's not useful for us, because if the if the destructor is called at the end of the program, this is unnecessary, because the length, width and height is deleted or are deleted by the destructive object. So we can rerun this program and we have no error. Okay, but one difference is that void get volume value, or this function, can be called now, like this one. We can define a double variable in here, like double volume is equal to 0 in the first place, and volume can be calculated by the length times width times height, and we can write it down like this one. Volume is the volume value, can be added in here. And so box 1 can call the get volume value or get volume function in here, and main calculates the volume value of the box 1, like this one. This is wonderful, because the default constructor sets the whole the variable in private section, and then the get volume function calculates the whole volume value by using the private section, and we get at the end of this program volume value. So main function includes only the class variable, which means that this is the property of the object-oriented notation or object-oriented programming. Easy, Baran, easy. And so we can define some specific function like this one, but we can pass this example in here, and so we can create a new example as an example 6 at this point. And now we can define a line class by using the same syntax. Int main function was also needed in here, and class line can be defined in here. Okay, and so public section includes the whole function block, because the function in the private section cannot be reachable in the main function because it's outside of the class scope. Do you get it? I hear yes, but I'm not sure. Okay, so public has the void set length function with parameter of double len, but now we have a different operation in here, as this is called the declaration of the function. And so double get length was also given here with the parameter of void, and line constructor can be added at that point. But we have some specific variable in here, double length. But how we can define this function block in the outside of the class? Don't worry. A compiler can give a way to define these declarations in the outside of the class. We have some specific operator which we call the resolution operator in here, like this one, dot dot dot dot. And we can define this function block in here. And so we can write it down is object is being created like God. Okay? But there is not God in programming. There is only God in the universe. So void line can be reachable. This function block in here, set length with a parameter of double len, can also be defined at this point. So this function is the function definition. But this is the function declaration at this point. And compiler can give away us to define this function block by using the resolution operator with a class name and return value. So a length can be assigned to len variable at this point. And in addition, double line resolution operator gets length, this given in the class section in here with a parameter of void. So this returns a length variable at this point. And so if we run this program, we don't have an error. So we can create the line object with the line 1 parameter in here, and then we can set the line length like this one, line dot line 1 dot set length. Thank you, İşcan. Thank you. God helps you. Okay. Set length with the parameter of 6, and we can write it down length of line with the line 1 parameter get length should be called in here with the endly. So we can run this program and we get the object is being created and length of line is initialized with the 6 parameter at this point. So in this lesson we have learned, or we teach by us, Professor Hüseyin and Mehmet İşcan, by using the class variable or class function, two methods are here. One of them, we can define how the function related to class can be included in the public section, or we can give the declaration of the function to the class in the class section, and then we can fill or we can define this function block with the using of the resolution operator like this one. Okay, but we don't have a destructive object or function in here, and so we need to add this, the line function, but we can define it the like the function definition block. In here, the compiler is okay with this definition, but we can define as a declaration function, and we can define it in the below of the class. But at this point, see out the object is being destructed. Destructed. I can't remember that. I'm sorry. At this point, okay? And so we can rerun this program, and length of line 6, and object is being created and object is being destructed in here. For the 5th special example session, we are finished, and so I hope you learn all the things or the beginning properties of the class property at this lesson. Thank you guys for listening to me, as well as Özent.